There are billions of planets in our galaxy. Most are so distant that humanity may never reach them. But one world is different. Only 4.24 light-years from Earth, orbiting the closest star beyond our Sun, lies a rocky planet that could forever change our understanding of life in the universe. It is the nearest world that might resemble our own. The closest place where another Earth could exist. This is Proxima b. When we look into the night sky, almost every visible star is separated from us by dozens or even hundreds of light years. Yet one star quietly sits much closer than all the others. It is Proxima Centauri, the nearest known star to our solar system. Although invisible to the naked eye, this tiny red dwarf has fascinated astronomers for decades because of its extraordinary proximity. Located just 4.24 light-years away, it is our closest stellar neighbor. In cosmic terms, that distance is astonishingly small. If humanity ever sends a spacecraft to another star, Proxima Centauri will almost certainly be the first destination. And orbiting this tiny star is a planet that may forever change our understanding of life beyond Earth. For years, scientists suspected that nearby stars might host planets of their own. But confirming their existence was an enormous challenge. In 2016, after months of careful observation, astronomers announced the discovery of Proxima b. Using the radial velocity method, they detected tiny movements in Proxima Centauri caused by the gravitational pull of an unseen planet. It was a historic moment. Humanity had discovered an Earth-sized world orbiting the closest star beyond our Sun. Suddenly, the dream of another nearby Earth no longer belonged to science fiction. It became an object of scientific investigation, one that telescopes around the world would continue studying for years to come. Proxima b is slightly more massive than Earth and orbits remarkably close to its star. At first glance, this may sound dangerous, but Proxima Centauri is far cooler and dimmer than the Sun. Because of that, Proxima b receives roughly the same amount of energy that Earth receives from sunlight. This places the planet within the star's habitable zone, the region where liquid water could potentially exist. That single fact instantly made Proxima b one of the most important planets ever discovered. If water exists there, then the conditions necessary for life might also exist. But being in the habitable zone is only the beginning of the story. At first glance, Proxima b seems to have everything scientists hope to find in another Earth. It is rocky, similar in size to our planet, and orbits within the habitable zone of its star. But life around a red dwarf is very different from life around the Sun. If you stood on the surface of Proxima b, the sky would never look blue. Instead, a dim crimson sun would dominate the horizon, bathing the landscape in deep shades of red. The star itself is much cooler than our Sun, producing far less visible light. Even at midday, the world might feel more like an endless sunset than a bright afternoon on Earth. It would be an alien sky. Yet beneath that red light, the conditions for liquid water, and perhaps life, could still exist. Because Proxima b orbits so close to its star, gravity has almost certainly synchronized its rotation. This phenomenon, known as tidal locking, means one side of the planet constantly faces Proxima Centauri while the other remains in perpetual darkness. Imagine a world where the sun never rises or sets. On one hemisphere, daylight lasts forever. On the opposite side, night never ends. Between them lies a narrow twilight region where temperatures could be moderate enough for liquid water to survive. Some scientists believe that if Proxima b possesses a sufficiently thick atmosphere, winds and weather could redistribute heat across the planet, making this twilight zone surprisingly hospitable. It may be one of the strangest environments where life could exist. There is, however, one enormous problem. Proxima Centauri is not a quiet star. Like many red dwarfs, It frequently unleashes powerful stellar flares, violent eruptions that release intense bursts of radiation into surrounding space. Some of these flares are hundreds of times more energetic than those typically produced by our Sun. Because Proxima b orbits so close, it receives the full force of these explosions. If the planet lacks a strong magnetic field or a dense atmosphere, billions of years of stellar radiation may have stripped away its air entirely, leaving behind a cold, barren world. The same star that could make life possible might also make it impossible. Despite these challenges, scientists have not given up on Proxima b. If the planet formed with a thick atmosphere, if underground oceans exist, if a magnetic field protects its surface, then life may still have found a way to survive. On Earth, life thrives in boiling hydrothermal vents, beneath Antarctic ice, and deep underground where sunlight never reaches. Nature has repeatedly shown that life is remarkably adaptable. Perhaps Proxima b is another example. Or perhaps it is a reminder that being in the habitable zone is only one chapter in a much larger story. The truth remains hidden beneath a sky no human has ever seen. Finding Proxima b was one achievement. Reaching it is something entirely different. Although it is the closest known potentially habitable planet beyond our solar system, it still lies an astonishing 4.24 light-years away. With today's fastest spacecraft, a journey there would take tens of thousands of years. Voyager 1, the most distant human-made object ever launched, would need roughly 70,000 years to arrive. For now, Proxima b remains beyond our physical reach. But history has taught us something remarkable. Every generation has declared certain frontiers impossible, until technology proved otherwise. The question is no longer whether the distance is enormous. The question is whether humanity can learn to cross it. One of the boldest ideas ever proposed is a project known as Breakthrough Starshot. Instead of launching a massive spacecraft, the concept envisions sending tiny probes equipped with ultralight sails. Powerful lasers fired from Earth would accelerate these probes to around 20% of the speed of light. At that velocity, the journey to Proxima Centauri could take just over 20 years instead of tens of thousands. The idea remains experimental. Many engineering challenges have yet to be solved. But for the first time in history, humanity has begun designing missions that do not simply explore planets within our solar system. They aim for the stars themselves. Long before humans reach Proxima b, our telescopes almost certainly will. Future observatories are expected to capture sharper images, analyze planetary atmospheres in greater detail, and search for the chemical fingerprints of life. Scientists hope to identify molecules such as water vapor, oxygen, methane, and carbon dioxide. Substances that could reveal whether the planet is geologically active or even biologically interesting. Each new telescope becomes another step closer. Every improvement in technology transforms a distant point of light into a real world with mountains, clouds, weather, and perhaps oceans. Proxima b is slowly changing from an astronomical measurement into a place. For thousands of years, humanity believed the stars were forever beyond reach. Today, we know one of them hosts a world that may resemble our own. Whether Proxima b is a barren rock, a frozen wasteland, or a living planet remains unknown. But its greatest importance lies elsewhere. It is the first destination that humanity truly dreams of reaching beyond the solar system. Every great journey begins with a single horizon. For our ancestors, that horizon was the next valley, then the next ocean, then the moon. Now, for the first time, that horizon lies around another star. Perhaps one day, someone will stand beneath the crimson sky of Proxima b and look back toward a tiny yellow star in the distance. The star we still call home.